Hello everyone, today we are going to explore a fascinating phenomenon in science which calls Tyndall effect. Although the name might sound unfamiliar to you, you'll definitely see it in your daily life. For example, the visible beams of sunlight streaming through a forest, the strong light columns created by stage light in the theaters, or even the highlights of a car on a foggy night. All of those are real-life examples of Tyndall effect. But why does this happen? It's because it all comes down to how lights behave in different dispersions, which are true solutions, colloids, and suspensions. So to demonstrate this, we will prepare 3 simple samples and shine a laser through them. So let's see what happens. First, let's prepare our 3 liquids. The first one is sugar water. We dissolve about 10 grams of white sugar into 500 ml of warm water, stirring until it's completely clear. Sugar molecules are extremely small, less than 1 nanometer, so this gives us a true solution. First, sugar water. As the laser passes through, we can see the beams exist on the other side, but there is no visible light pass inside the liquid. That's because the molecules are too small to scatter light effectively. In true solutions, the solute particles are smaller than 1 nanometer. That's very small compared to the wavelength of visible light, so there is essentially no scattering. Experimental result about true solution. When irradiate sugar water with a laser pen, although the laser can be seen from the other side, there is no light path in the liquid at all. This proves that sugar water is a true solution and will not produce a Tyndall effect. The second sample is milk, or you can also use soapy water. Milk also contains fat droplets and proteins of similar dimension. This time, the result is very different. The laser creates a bright, visible beams inside the liquid, almost like a glowing tunnel. This is a classic Tyndall effect. Meanwhile, the colors particles are the right size to scatter light into our eyes, making the light path visible. So the experimental result about colloids. When it irradiates the milk with a laser, we'll find a bright column of light in the liquid, as if the light has opened a channel in the milk. This is a very typical Tyndall effect. For the third sample, let's prepare a cup of suspension. Take 500 ml of water and half a spoonful of flour and stir vigorously until the water is full of floating powder. So at this time, what we got was a glass of turbid flour water. As you see, the liquid looks cloudy, and when we shine the laser into it, the light is blocked and scattered by the large particle. We don't get a clear light beam, only a blurry glow. The experimental about suspension. When we shine the laser on the flour water, we can see a complete light column, but only some weak red light spots. This shows that the suspension does not show the typical Tyndall effect.